Logarithmic functions. Let's start off solving a few equations that we know how to do. In this first problem, if I give you the equation 2 to the x equals 4, you know that 2 raised to the second power gives you 4, so that means x is going to equal 2. In the second equation, 2 to the x equals 8. Again, 2 raised to the third power is going to give you 8, so x equals 3. But when we look at example number 3, it says 2 to the x equals 6. 2 raised to any exponent. We don't know what that exponent is going to be to give us an answer of 6. So let's use a logarithm. What is a logarithm? The logarithm of y with base b is denoted by log b y, and it's defined as b to the x equals y. Now, where did that x come from? We're going to take log by and set this equal to x, and that's how we get the definition of a logarithm. The expression log little by, it's read as log base b of y. So you're always going to read log base b, whatever that little number is, of this number. Now, when we're moving from the logarithmic form to the exponential form, you want to use the heart method. And what that heart method is, you're going to start with the b, and you're going to go over to the x, hit the equal sign, and then the number. So we have b raised to the x power equals y, and that's how you get your exponential form. So let's practice changing from exponential to logarithmic form. Example 1 is given to us in logarithmic form, so let's change it to exponential. So let's use the heart method. Start with the 4, go up to the 2 equals 16. So we have 4 raised to the second power is going to equal 16. Now let's convert this one as well. 3 raised to the fourth power equals 81. 3 raised to the fourth power equals 81. In these next two examples, when we're changing from exponential into logarithmic form, we can still use the heart method. You just have to remember a couple things. So we're going to start with the 2, go to the 8 equals 3. Now the only thing is when you're actually writing this, you have to remember to write the word log first. 2 is going to be the little number, and then 8 is the regular size number, equals 3. So we'll use that same thing here. 4 1/4 equals -1. So log base 4 of 1/4 equals -1. Let's evaluate the logarithm without a calculator. So our first step is to convert it to exponential form. So if we set this equal to x, we can convert this. 15x equals 15. So 15 raised to the x power equals 15, and 15 raised to the power of 1 will give us 15. Example 2, set it equal to x, then convert. 2x equals 1/2. So 2 raised to the x power equals 1/2. So how does a number turn into a fraction? Remember that negative exponents will cause you to take the reciprocal of the number. So since 2 changed to its reciprocal 1/2, x is just going to be -1. Don't forget about your negative exponents as we work with logarithms. In example 3, let's go ahead and set this equal to x, then we can convert. 2 raised to the x power is equal to 6. Here's that problem again that we worked with at the very beginning of this lesson. 2 raised to what exponent will give us 6? We don't know that. So there's something else that we can use to help us find that. The change of base formula. You can use either the common log version or the natural log version. The common log is log base 10, and natural log is log base e, otherwise known as ln. So when we use the change of base formula, we're going to take log base b of v, and that is the same as log base 10 of v divided by log base 10 of b. Natural log is the same idea. Log base b of v is going to be natural log of v divided by natural log of b. So let's go ahead and evaluate these logarithms using a calculator and the change of base formula. So we're going to take log base 10 of 9 divided by log base 10 of 8, because your calculator will only compute logs with base 10. That's why we're changing this into the common log. Or, example 2, let's go ahead and use the natural log. We can do natural log of 13 divided by natural log of 5. Now in class, we'll take out the calculators and we'll work on this final step of evaluating the logarithm, but the most important part is using the change of base formula. Be comfortable using the change of base for either the common log or the natural log. Next, let's talk about the power law. The power law talks about taking a logarithm when you have an additional exponent. So we have log base b of a raised to the c power. What you're going to do is you're going to take that exponent and bring it down in front as a coefficient. So c multiplied by log base b of a. This is one of the logarithm properties that we'll also talk about later, but I just wanted you to know this one first so that we can work out a couple examples. Let's go ahead and simplify these expressions. The first thing we're going to do is take this x and bring it down in front as a coefficient. So we have x times the log base 2 of 2. Now what we want to do is we want to take this part and we want to convert this into exponential form. So let's go ahead and set log base 2 of 2 equal to, let's use a different variable, so y. And when we convert this, we have 2 raised to the y power equals 2. Now 2 raised to what power equals 2? That would be 1. So that means this entire thing inside the parentheses is really equal to 1. And then we have x multiplied out front. So when we simplify, it's really just x. So let's go ahead and do this with example 2 as well. We'll take that exponent, bring it out in front. So this is really x times the log base 3 of 9. And then let's go ahead and take what's inside. And we're going to set this equal to y. And then let's convert. And 3 raised to the second power is going to equal 9. So that means all of this here is equal to 2. So x multiplied by 2 gives us 2x. So this is how we're going to simplify expressions using the power law. Now just a few things I want you to remember. The natural logarithm is base e, and that's denoted by log base e or ln, the natural log. A few special logarithm and natural logarithm values. You don't have to memorize these, but if you do know them, it will make some of your work a little faster. Log base b of 1. So any base of 1 is going to equal 0 because any number raised to the 0 power equals 1. Log base b of b. So if the number for the base and the number here, if they're the same, the answer will always equal 1 because when you convert this, b to the first power equals b. Log base b of b raised to the x is going to equal x. Because when you convert this, b to the x equals b to the x. The natural log of e will equal 1 because e raised to the first power equals e. And then natural log of 1 equals 0 because e raised to the 0 power is going to equal 1. That's it for this lesson. I'll see you in class for more practice.